Let's practice using the ideal gas law. This problem asks us, what is the volume of 100 grams of water vapor at 120 degrees Celsius in 1 atmosphere? Let's remember that the ideal gas law is PV equals nRT. So let's look at our problem here and see what variables we already have. Let's start with pressure. The problem gives us 1 atmosphere of pressure, so we have our pressure, and 120 degrees Celsius is our temperature. Now we know we want our temperature to be in units of Kelvin, so let's do that conversion first. So 120 degrees Celsius plus 273 gives us our 393 Kelvin. Next, we need to know if we have our constant, our ideal gas constant. And because it's a constant, yes, we have it. 0.0821 liters atmospheres over moles Kelvin. And this helps us check that we have the correct units. So now we have our Kelvin and our atmospheres, and we're looking for our volume. And we'll make sure that our volume is in liters, which it will be because we're using this constant. And then we need moles. So does the problem give us moles? In this case, it gives us our mass, but we can convert this using a molar mass, and that will give us our moles. So that's the first calculation we need to do. So we're given 100 grams of water vapor, which is H2O. Using the molar mass from the periodic table, that is approximately 18 grams per mole, and that gives us 5.56 moles of water vapor. So now we can go ahead and do our calculation. So we'll rearrange the equation slightly by dividing both sides by pressure. And we're given this setup so that we can fully calculate out to get our volume. So for moles, we have 5.56 moles, R, our ideal gas constant, and T in Kelvin, our temperature. Now this all gets divided by our pressure, which is 1 atmosphere. Now if you get out your calculator and calculate through, we get 179.4 liters, but we see in our problem that we're given 3 significant figures, so we know this will be 179 liters as our final answer.